Hi everyone, and welcome to our pitch presentation. We are Holo3, and we're here today to redefine the future of design. As you may know, humans are 3D creatures, and we see the world in 3D because our brains are able to perceive the depth of the surrounding objects. By far, however, we've been interacting with computers in a very unnatural, sort of 2D way. We use computers, phones, and tablets to design and visualize data, but our computers and phone screens only show us a 2D version of the world. And we've been trying to create 3D objects using a variety of 2D tools, but it's just artificial. It doesn't feel natural or normal the way we should design things. For example, if I look at a concept car design on my laptop, people on the other side of the room can only see the back of my laptop lid instead of the car design, and that's artificial too. In today's world of technology, we relied heavily on computers, smartphones, and other electronic devices to design virtually anything. However, we're not able to touch or feel this virtual design because we can only indirectly interact with the design objects via the screen. As a matter of fact, these technologies are not capable of allowing designers to make adjustments to the designed objects with physical interaction. Most of the time, for designers and engineers, they design something virtually because they want to see how the final product looks like, or to understand the fundamentals of how things should work based on the design. For instance, architects design a house model not because they just want to see the model, but because they actually want to see which arrangement of furniture would be nice, or whether red or blue should go with the house. In other words, they want to see if things work out in real life based on the design. However, instead of focusing on figuring out the right styles or materials for the house, they first need to learn how to make computers make the design to be able to see it, which is a huge waste of time and eventually slows down the whole work progress. And that is why our team are looking into developing a 3D design concept that eliminates these problems all at once. So we went to look at 3D projection and hologram to make this 3D design concept become reality. And for those of you who don't know what hologram is, it is a 3D virtual object that isn't actually there, but it looks as if it were, either floating in the middle of the air or standing on a nearby desk. And we believe that if you can just jump in there, do what you need to do, and just focus on understanding the fundamentals of how things should work, as opposed to figure out how to make computers or devices make it work, then you can achieve a lot more in a lot shorter period of time. In other words, we can build the final product much faster and more efficient if we have all the design process automated and done for us. Working on these solutions, we decided to build Holo3, a device that relies on hologram technology and 3D projection, but it's much better than that. It is a mixed reality device, a combination of virtual reality and augmented reality. Holo3 works as a 3D projector that makes the objects float in the air. It provides a holographic 3D user interface with the implementation of motion sensor and voice activation. Different from traditional hologram technology, Holo3 allows actual interaction with the designed objects, where users can manipulate the forms and shapes of the objects by grabbing, rotating, zooming, spinning, and translating objects using hand gestures. Holo3 can also support design automation. With AI-powered technology, users can demand the device to automate multiple design tasks simultaneously by using the voice activation. With this feature, design content can be produced and created with minimum time and effort, and users can save their brain powers to achieve more than just making the design. Besides being able to visualize the objects in 3 dimensions, Holo3 can also provide data related to the making of the design, such as design objects, shapes, forms, colors, and any other relevant data used for analytics and research purposes. According to Algan's article from Computer World, one of the greatest benefits of 3D hologram displays is making digital content more human compatible. With the ability to interact with and manipulate in-progress designs, the design process will be enhanced significantly to help users to be able to create functional products from it. This innovation will contribute to a wide range of fields. According to the research article on the improvement in hologram for 3D display, there are now many applications of holography in art, architecture, scientific research, engineering, and medical assessment. Some uses of holography in medical assessment mentioned by Higgins and Mishra include the use of holography in volumetric assessment of tumors, analysis and storage of dental models. In accordance to the multiple fields and industries that benefit from 3D holograms, there are a variety of ideal users that would also find Holo3 extremely helpful. Designers would be an example. Designers can design and style content in a more intuitive and faster way with Holo3 compared to using the traditional 3D modeling programs on computers. Besides, architects can use it to visualize options in the constructions of buildings. Doctors can also use the Holo3 because the 3D hologram technology will enable physicians to zoom in and out of the images to get a better view of parts that are uncleared in the initial scans. The transformation technology of 2D images into 3D floating projections will revolutionize the way medical professionals plan and carry out their treatments and surgeries. Besides, medical students can also use it to explore human anatomy. Also, according to the research report by the group of Japanese scientists on holography applications, three-dimensional holography is also important for science and engineering. Specifically, engineers can utilize Holo3 for constructing engineering models and learning about the fundamentals of how things function. For scientists, Holo3 can also be used to visualize data, objects, and structures in an intuitive way, such as analyzing geographical features, weather conditions, and chemical reactions. We are already seeing applications for all these emerging hologram effects coming from traditional electronic devices, such as computers, smartphones, and tablets. But the real benefits come when holograms are liberated from such devices, where users can touch and interact with the designed objects itself. For AR and VR headsets, the hologram will still be in effect, but it does require some kind of lightweight equipment, such as AR glasses attached onto the user's face to be able to see the hologram. With Holo3, on the other hand, there will be no need of any attachments for users to be able to experience the hologram effect. Instead, Holo3 device has the arrays of virtual lasers coming out, which enables users to grab and manipulate the floating holograms. We believe that this innovation will be on the verge of a major breakthrough in design and engineering, in being able to take the concept of something from your mind, translate that into a 3D object intuitively on Holo3, and eventually we can take that virtual 3D object and be able to make it real. It's going to revolutionize design and engineering industry in the 21st century. Over the years, the challenges of creating a 3D image in the thin air simply seem insurmountable. Finally, however, it looks like we are approaching the day where that dream of real holograms may actually become a reality. Scientists around the world have come up with new and inventive ways to use lasers, modern digital processors, and motion sensing technologies to create several different types of holograms which could change the way we consume and interact with the media in the very near future. Besides, holographic technology is expected to become a huge game changer in many industries and has the power to significantly impact our daily lives. We only discussed a few examples in our pitch, but the potential applications are nearly endless. Think about real estate, space research, 3D mapping technologies, architecture, interior decorating, emergency assistance in remote areas, telemedicine, manufacturing, remote video conferencing, education, and many, many more. Regarding the current impact of holography on different economies, according to Global Industry Analyst Report, holography for industrial applications market alone is projected to grow by over $7 billion globally in 2020, driven by a growth of nearly 6%. But just like any other data programs on computers and smartphones, the data on Holo3 is also stored and transferred between the device system and the cloud system. For that reason, it is no doubt that the data can still be hacked and manipulated by third-party users. So we actually need to take into consideration the vulnerability of data privacy and the importance of data protection and cybersecurity. So that's it about our presentation, and thank you for your listening.